Over the last 18 months or so, you've experienced your fair share of earthquakes, of major ones. Tell me about that.
Well, at the time of the Darfield earthquake, I actually wasn't here. I was in Macedonia. There was an earthquake engineering conference, the European one. And so we heard about the Darfield earthquake while we were at this conference. And of course, our initial thoughts were, we feared for the worst. But it turns out that, that was quite a success story. We felt, no one was killed. It seemed quite remarkable at the time, and we kind of lauded our performance in that event. Then, of course, 6 months later, the 22nd of February earthquake happened. The shaking was much stronger because the earthquake was a lot closer to Christchurch, and unfortunately there were fatalities in that earthquake. I happened to be living in Japan around that time, but I'd travelled back 3 days beforehand. So I arrived in New Zealand 3 days before, and then the 22nd of February earthquake happened. So I stayed here for a few weeks, but then ultimately I was based in Japan at the time, so we returned to Japan on the 7th of March 2011. And then, of course, 4 days after we arrived back in Tokyo, there was the 11th of March Tohoku earthquake, the magnitude 9, which we all know about since then. So, of course, that was another event completely different than the situation here in Christchurch. Rather than sort of a moderate-sized earthquake extremely close to a city, this was an absolutely massive earthquake, 500 kilometres long, which occurred quite some distance from Tokyo, but because of the size of the earthquake, the shaking in Tokyo was extremely strong. The fundamental different nature of the shaking was something which was really just quite profound. That in the Christchurch earthquake, the shaking, although it was very strong, we were talking about ground shaking levels above 1G, that shaking lasted for a very short amount of time, on the order of about 5 to 10 seconds of strong shaking. So by the time you realised what had hit you, the shaking had basically started to settle down and stop. In the Tohoku earthquake in Japan, exactly the opposite thing happened, where the ground motion started, you started moving, and that intensity of shaking built up over quite a period of time, and it really took about 40 seconds for the earth to really start moving. And from that point where it sort of really reached its peak, it sort of maintained that level of shaking for another 2 or 3 minutes. And so you really had a chance to think to yourself, what should I do? How am I going to get myself out of this? What can I do to get the best result for myself? Which is a completely different effect to what happened here in Christchurch, where it essentially was finished by the time you knew anything about it. Again, they were completely different situations, one in a relatively small city of about 400,000 people, where you are relatively independent. You can get your way home, you tend to have a lot of storage and things at your house, so you can be quite self-sufficient. Whereas in a large mega city like Tokyo, you're far more dependent on the infrastructure, and you have a lot less things stored in your house. So really, in Tokyo itself, there was not a lot of damage, but it was more the fact that as a result of the problems with the nuclear power plants, they were trying to save power. And what that meant is they changed the schedule of the trains. And for anyone that's been to Tokyo, they know that essentially Tokyo runs on a magnificent train system. But when you upset that system by just a little bit, delaying every second train, then that caused essentially utter chaos, and it was a problem more with the delivery of goods to certain places than it was with actual damage. So at that time we left Tokyo and we came back to New Zealand, and that was just because of the disruption there in Tokyo, but it also provided me an opportunity to spend another month back here in New Zealand and collect a lot of field work, which I was obviously keen to do.
Well, the last 18 months in Christchurch, interesting times for an earthquake engineer.
Oh, absolutely. I mean, these are the things we spend our whole life looking at, and we always expect that sooner or later there are going to be things happening, but we never necessarily expect it to be in our own town and to be so devastating. So I feel quite fortunate that it happened at what I think is a good time in my career, that I'm sort of old enough to make a contribution, but also young enough to really set the sort of foundation for what I want to do from here, and really provide a good impotence for what's important and what's of lesser importance. the sequence essentially started with the 4th of September 2010 Darfield earthquake. And prior to that earthquake, the level of seismicity, which means the frequency at which we have earthquakes, was relatively small in Christchurch itself. But essentially what happened is after the Darfield earthquake, that movement of the crust caused stresses to completely change around the Canterbury region. And that change in stresses caused some areas to reduce, but some areas also to increase in stress. So if we had a fault which was previously had some level of stress on it, and then, for example, because of the Darfield earthquake, it caused an increase in stress on this particular fault, then what we can get is now that fault happens to break because of that increase in stress. And that's essentially what happened in the period of the 6 months after the Darfield earthquake. That stress was transferred within the crust onto the fault which eventually broke in the 22nd of February earthquake. And that type of earthquake we would call a triggered earthquake. That the 22nd of February fault was eventually going to break, but we don't know exactly when. And so that Darfield earthquake essentially provided an increment in the stress on that 22nd of February fault, and that therefore triggered that fault to occur probably earlier in time than it would have otherwise. When we talk about the number of aftershocks, we have to remember that it's a fractal process, so that we have about 10 times more magnitude 5s than we have magnitude 6s, and therefore also about 10 times more magnitude 4s than 5s. So when we talk about how many aftershocks we've had, we really have to qualify that by saying how many above a certain magnitude. So if we talk about how many have we had above magnitude 6, then we've had about 3. But if we talk about how many we've had above magnitude 3, then we've had probably in excess of about 2,000 or 3,000, and above magnitude 2, probably in excess of 10,000.
And how long is it going to continue for?
Well, we know that if we think fundamentally about what's causing this, it's the fact that during that Darfield earthquake we had a redistribution of stresses in the crust. Okay? And everything that's happened since then is the Earth's way of trying to distribute those stresses and release that energy to get back to a state of equilibrium. As we get closer to that state of equilibrium, then the amount of earthquakes that we have should be reducing. So we expect a general decay in the number of earthquakes with time. However, every earthquake again triggers additional stress in the region. So what we saw, for example, is we had the Darfield earthquake, and then the number of aftershocks started to decay with time, but then eventually we had this 22nd of February earthquake, and that regenerated the stress in the region. And then that earthquake had its own aftershock sequence. So what we tend to find now, where we are at the end of March in 2012, is that these earthquakes have become less frequent than what they were 6 months ago, but that's not to say that we're not going to have another large earthquake which would again have its own aftershock sequence.
But ultimately, do we need to reassess the seismic hazard for Christchurch and surrounds?
Well, we're always assessing the seismic hazard, throughout different seismically active countries in the world. And the difficulty with seismic hazard is that the amount of time that we've been observing earthquakes and trying to quantify them is on the order of 100 years. But these earthquakes are happening at a geologic scale. They're happening over hundreds of years, thousands of years, even some of them tens of thousands of years. So really our period of observation is extremely small compared with the period at which these earthquakes are occurring. And therefore we have very little knowledge of these processes because it's so complicated. So we're always trying to improve our estimate of what the hazard is, but also the hazard is not just a scientific question, it's a public perception question. So we have to decide not only how likely are we to have this level of shaking, for example, that we've had in Christchurch, but also when we have that level of shaking, what should we be targeting as the performance of our built society? Do we want to have no damage and therefore build structures which are potentially a little bit more expensive, or are we willing to accept that damage and carry on as we do things now? And I think that public perception is something which always changes with time.
Cities like New Orleans get hit by a big hurricane and flooding, and people question, well, is it really built in the right place anyway? Is it a valid question to ask of Christchurch?
Absolutely, and I think, the idea of planning things in advance is, the old saying that an ounce of prevention is worth a pound of cure. So I think if we do good planning, for example, if we build houses in areas where we know the ground conditions are stable, the chance of liquefaction is low, then in future earthquakes we can expect that liquefaction effects are not going to cause significant problems to our society. So the ultimate way for prevention is to essentially eliminate the hazard by not constructing houses or structures that are particularly vulnerable. But of course, at the same time, often we are designing different things in society and later from experience realising that maybe this was in a hazard-prone area. So it works both ways. If we can prevent ourselves from being exposed to a hazard, that's good, but often we find that we're exposed to a hazard after the fact that we've already constructed these things in society. The benchmark earthquake that happened in New Zealand was the 1931 Napier earthquake, which was in the North Island. And what happened in that earthquake was a 7.8 magnitude earthquake, which caused huge devastation to Napier, killed 231 people, and essentially obliterated the city. Now, that earthquake was absolutely profound in that people realised the destruction that earthquake can cause to cities, and one of the major changes after that earthquake was that in New Zealand it was no longer possible to build unreinforced masonry buildings. So that was one outcome that happened from that earthquake in New Zealand. Now, since that time in 1931, New Zealand's been extremely fortunate in that while we've had earthquakes that have been large, none of these earthquakes have happened near large population centres. So we've had earthquakes in Fiordland, in the centre of the South Island, but these are not highly populated areas. So to some extent, New Zealand has forgotten a little bit about the potential risks that earthquakes can cause. And this Canterbury earthquake sequence has really revived that, how significant these earthquake events are. I mean, we talk about the fact that prior to the Canterbury earthquakes, since 1931, more people had been killed in Australia from earthquakes than had been in New Zealand, which is quite an amazing statistic given the number of earthquakes we have in New Zealand compared to Australia.